Hello, everybody. I think you can all hear me. So welcome along to this session, the Oceania session. What are we, the Eastern Hemisphere? We've got a range of talks today. They're fast, 5-minute talks with a little bit of space for questions and changeover afterwards. And then we'll have some time, hopefully at the end, where we can go for a deeper dive into conversations and further questions. First off, I'm speaking to you from Lutruwita, Tasmania, which is Aboriginal land, sea and waterways. And I acknowledge with deep respect the Muanina people, the traditional owners of this land on which I'm speaking to you from. The Muanina people cared for and protected country for thousands of years. They knew this land, they lived on this land, and they died on this land, and I honour them. I pay my respects to elders past and present, to the many Aboriginal people that did not make elder status, and to the Tasmanian Aboriginal community that continue to care for country. I recognise a history of truth which acknowledges the impacts of invasion and colonisation upon Aboriginal people, resulting in their forcible removal from their lands. I stand for a future that profoundly respects and acknowledges Aboriginal perspectives, culture, language and history, and a continued effort to fight for Aboriginal justice and rights, paving the way for a strong future. And I want to acknowledge the First Nation peoples of all of the lands that we're all from. So. With that said, first up we have Daniel Silk presenting from Aotearoa, maybe I can say it right, New Zealand. He's from LINZ, so over to you, Daniel.
Cool. Yes, did you need a verbal cue? Cool, I did. Thank you very much. Cool, thanks, Alex. Yeah, hi, my name is Daniel Silk, and I'm a product owner in the topography team at Toitū Te Whenua Land Information New Zealand. It's great to be part of the event today, and huge thanks to the organisers for providing a time slot that's friendlier for us in this part of the world. As a bit of background, Toitū Te Whenua is the New Zealand government department that manages land titles, geodetic and cadastral survey systems, topographic information, hydrographic information, and Crown property. Our Basemaps product makes it fast and simple to create maps using our free, open and authoritative topographic data. This includes the development of vector tile services, but the lightning talk today will focus on our aerial imagery service. We collate aerial imagery sourced from local and regional councils around New Zealand into a single national view. We provide WMTS and XYZ services so that our customers can easily bring aerial imagery into their maps. The service includes Sentinel-2 imagery at low zoom levels, and then brings rural imagery into view as you zoom in. This is 30 centimetre rural imagery outside of Wanaka. At the highest zoom levels in urban areas, we are showing 5 to 10 centimetre aerial imagery. This is 5 centimetre imagery in Christchurch. All up, there are over 130 individual aerial imagery surveys that have been combined to create this product, each consisting of thousands of individual TIFF files. 40 of those are new imagery surveys that have been received since we launched this product a year and a half ago. So when the product team kicked off, we created some development principles. We needed the product to be low maintenance. The product team is small and cannot be burdened by having to maintain a lot of infrastructure. It needs to be scalable. The system should be able to handle thousands of concurrent users. Highly available, should be no noticeable downtime for system upgrades or deployments. Open, the system should be open to the public, use open standards and share its source code. Should be traceable, everything should be monitored and tracked so that when errors occur, they're easy to track, reproduce and fix. And low costs, as this is a consumption-based service, we pay the cost of serving the tiles, so the system needs to be cost effective. With these principles in mind, product development started by funding some GDAL enhancements. While proof of concept work was being undertaken, we ended up with a script that ran a number of different GDAL commands in order to process our source imagery TIFFs into cloud-optimized GeoTIFFs. We funded the creation of the GDAL COG driver as a convenient wrapper around the GeoTIFF driver to optimize and simplify this workflow. We have since contributed additional features, for example, support for different compression methods for the main image and overviews. So for our COG creation process, first our supplied TIFFs are stored in S3 with accompanying STAC metadata so that we can process them in the cloud. This is an example of one of our source urban aerial imagery datasets. As you can see, it's quite spread out, covering different urban areas with almost 2,000 source files. We then determine the survey extent of all of the source files, source TIFFs, and we split the tiles into smaller processing groups that align to a tile matrix set, for example, Web Mercator Quad or NZTM 2000 Quad, which is our local projection coordinate reference system. We are working with sparse data sets, which is quite challenging. We need some smarts to efficiently slice imagery into separate jobs for batch processing, and we need to optimize our COG creation so that COGs mostly contain data rather than empty space. This all gets quite complicated with different projections and different tile boundaries to align to. But we've built those algorithms into the process and can determine a processing queue, basically which TIFFs need to be processed to create an optimal set of COGs. We take that processing queue and create COGs on EC2 spot instances using AWS Batch. And new STAC metadata is created during the process and also stored in S3 alongside the COGs. Imagery configuration files determine how the imagery is layered into the final product. To achieve our goals of system visibility and low maintenance, automated notifications are shared to Slack on job completion, and automated pull requests are raised against the imagery configuration in GitHub. We can then view the newly processed set of imagery in the browser, make sure that everything looks good. So in order to service data to the users, we have our bucket containing COGs with STAC metadata and sourced from the various aerial imagery surveys. We then have a Lambda function which combines and flattens those COGs into images based on our configuration logic. And we serve those images out to Basemaps users. So onto some stats from our production service. We've served over 2 billion tiles since launch a year and a half ago. In the first couple of weeks, our service was shared on Reddit, which caused a peak of 2,000 requests per second, which the system handled fine, and 99% of all tiles are composed in under 300 milliseconds. That's all I have time to share today. You can view our service at basemaps.linz.gov.nz. You can find the source code on GitHub, and you can contact us via email, or we'll be in the Get a Chat to answer questions. Finally, a huge thank you to everyone that has contributed to the open source technologies and the open standards that our service uses. We couldn't have created this product without your efforts. Thank you very much.
Awesome. Thank you, Daniel. I'm impressed that you managed to survive the Reddit hug of death, notorious hug of death. Have we got any questions bouncing around on the Gitter? We do not. I'll pause for a little while. I'll just to let everybody know, if you can join Gitter to ask your questions. And I think I can send, I'm not sure how to message everybody, but if you do put questions into the chat, then I'll try to respond to those as well.
Cool, we'll stick around there as well.
Cool. Thanks, Daniel. Great talk. Fantastic.